Okay, so now we're going to look at quadratic equations, and we've seen some quadratic equations before. We saw quadratic equations when we were taking x squared and transforming it. All right, so remember that the x squared graph has a point right here where it goes from going down and then goes to going up, or if it's turned over, it would go from going up to going down, and that point is known as the vertex. And on the x squared graph, that vertex is 0, 0. There's also something called an axis of symmetry that goes through that vertex, and it's a vertical line that goes through the vertex, and it's called the axis of symmetry because the graph is symmetric on both sides of that dotted line. In other words, if I were to fold the graph along this dotted line right here, along the y-axis, the two pieces, had I drawn them perfectly, would land on top of one another. So we're going to concentrate on finding the vertex and the axis of symmetry for a quadratic that's in what we call standard form. Okay, now, we did graphs before where we transformed the x squared graph, and recall that what was out here was a vertical shift, so this took it up 5. And then what was inside the parentheses was a horizontal shift, and it was always opposite of the sign, so this was right 2. All right, well, if we think about this graph right here going right 2 and up 5, the vertex is usually right here, but if I moved it right 2 and up 5, it would be right here. And we'd have that same function we've been drawing all along. Now, the truth is, though, we don't have to draw it if we realize that, okay, let's notice that this point right here is 2, 5. So the vertex of our function is the opposite of what's written right here and the same as what's written right here. So the vertex is opposite of this, so 2, same as this, 5. And the truth is we don't have to go through the graph as long as we remember opposite of this, same as this. The axis of symmetry is the vertical line going through that vertex, going through this x value. And recall that vertical lines have equation x equal, and in this case, it's the x value of 2. All right, so we can do this without actually graphing. All right, so let's go to the next one, and let's do it without actually graphing. The vertex is opposite of this, so -4, same as this, -3. The axis of symmetry is x equals the x value of the vertex, -4. And that's it.